We're here to show you how you can enable multi-cloud with Istio. And the way we're going to do that is stretch the Istio mesh across the multiple clouds. We're going to use a public cloud and a private cloud, and we'll show you a demo. Quite a bit of this talk is around showing you how we actually implemented the work. So there's a few slides on that. My name is John Joyce. I'm with the Cisco Cloud CTO Computing Group.
My name is Robert Lee. I'm a lead software engineer at Cisco.
So this talk, we're really not going to go into use cases of why you might want to do multi-cloud or which applications or services could take advantage of multi-cloud. That's not the purpose. There was earlier talks, I think, that covered that. This is more about how you do it and showing you an example of actually doing it. So we'll give you a little bit of an introduction of Istio and a service mesh. Are most people familiar with Istio and what a service mesh is? Or is there anybody that's not really familiar with that? Okay. Well, we have a few slides, so I'll try to go through them quickly since most people are familiar with it. But then we'll talk more specifically about some of the changes we did to enable the the multi-cluster in Istio. And then we'll get into the deployment details and then the actual demo. Okay, so the goal here is to be able to, as microservices, as monolithic and larger services get decomposed into microservices, what we want to enable is that those microservices can run anywhere, on any cloud, in any environment, and you can do that safely and securely and not have to worry really too much about the placement. And the way we're going to do that is with Istio, because Istio provides some of that security, some of the efficiency, some of the programmability, some of the routing rules to allow you to achieve that separation and allow you to not be as worried about the placement of your microservices. So just a quick bit on what a service mesh is. A service mesh is a mesh of proxies that you act as like the front end to the API between the microservices. So what I'm showing here is that you have a bunch of microservices, or it's kind of a bit arbitrary what they may be. They have APIs between themselves. Those APIs could be various protocols, different formats, and what the mesh does is allow sort of an infrastructure that provides a common infrastructure for these microservices to communicate securely with each other. So what we're showing in this demo is doing that with Istio, and we'll talk a little bit about the details. I'm not going to talk about all the advantages. Some of them are listed here, but since most people are familiar with the service mesh, you can kind of just read that. In the case of Istio, the proxies are sidecar injected, so there's a nice separation there between the application and the actual proxy itself. So this is the Istio architecture. It's the figures borrowed directly from Istio.io. It's a bit dated with some of the naming. There's been quite a few naming changes in 08. So I would encourage you, if you really want the details, to go to Istio.io, but I'm trying to convey a little bit of an architecture so you get a feel for what Istio is and how it runs. Pilot is the piece of Istio that controls the proxies and creates the mesh for the proxies and has a view of the entire topology. Mixer provides telemetry. It also provides some policy checks, a little bit higher level security for server side. When the request comes to the server, Mixer is able to do a bit more authentication. The Istio Auth has been renamed Istio Citadel, and that provides the certification of the certs to Envoy so that it can certify both application traffic and inter-control plane traffic between like Envoy and its communication with Pilot. So what did we do with multi-cluster? So with multi-cluster, the most important thing is that you were able to get the service and endpoint information from all the clusters over to Pilot. in this scenario here, the Istio community might have different ways of doing this. We're exploring different ways to do this, but at the current time, what's supported is that there's a single pilot that communicates with all the API servers from all the clusters, regardless of what environment those clusters are running in. Okay? So each Istio pilot gets the service and endpoint data from all the other API servers, and then additionally, so a little bit on how we did that. So we borrowed the SIG MultiCluster cluster registry as the source of where those clusters reside, not where those clusters reside, but which clusters we want to connect with. So we used an Airly form of that. We actually don't do an API call. It's more a file-based call right now. But we are planning to extend that in the future to take full advantage of the cluster registry and do API calls over to the cluster registry to get the set of clusters that are should be part of this multi-cluster mesh. So based on the cluster registry information, we create a controller and pilot that then goes off and interacts with each of those API servers to get the service and endpoint data. And this shows what we do with it. So in this figure, the on-prem is sort of the left-hand side. The right-hand side is a GKE-based cluster, and we're running pilot only in the GKE-based cluster. And basically what pilot will do, based on the cluster registry information we push to it, it will interact with all the kube API servers on all the clusters. It'll get the service and endpoint data, and it will also get config data relative to like Istio route rules and stuff like that, and it combines that in and pushes it into what we call pilot discovery. So pilot discovery is a cache that represents the entire XDS database for Envoy. So when Envoy does an XDS request to get its CDS, LDS, RDS, its XDS information, Pilot's able to push that out to it. Okay, so alongside of the actual service and endpoint discovery, this is kind of explaining what we do to have Envoy be able to talk to a single pilot and get the discovery data. So what we do there is the way Envoy is configured with just a generic DNS entry on, a generic service name for pilot and mixer. So what will happen is when Envoy comes up, it does a local DNS query of where is my pilot, where is my mixer, that ends up pointing back to the single cluster that's hosting pilot and mixer, and then it just does a normal XDS discovery. If you're all familiar with Envoy, it's just a protocol interaction to get its XDS information. So in order to do this, what we have to make sure is that pilot, there's a service representation for pilot and mixer in every cluster, and we do that via headless services. In addition, what we have to make sure is that the certs that both the Envoy needs at the data plane level to communicate with pilot, as well as the certs for the applications to communicate with each other, are available. And the way we do that is we run Istio Citadel in each cluster, and then all those certs are chained back to a single root certificate. This slide sort of shows the procedure we use to achieve that. Okay, so now a little bit on the deployment that you're going to see. So a couple things that for this particular deployment demonstration, some of the environmental requirements, you must have IP reachability between the clusters. In the particular demo you'll see, we actually expose the pod IPs on all the clusters. So you have pod reachability across the clusters, and we take advantage of that. You don't have to use the pods. There are other ways you could do this. But in this particular demo, we use pod IPs and have reachability across those IPs. The other thing is that your microservice itself is going to take advantage of DNS and use DNS to resolve its peer services. So if you have a service that doesn't have an instantiation on a particular cluster, you need to do something in DNS to make sure that that service name is represented back on, let me explain that a bit differently. If you have a service in pod A and a service in pod B that wants to access the pod A service, you have to make sure there's a representation in pod B of the, not pod B, cluster B of the service that you want to access. So we do that again with headless services. And Robert will get into a little bit more detail on that in a minute. This is, I kind of showed this figure a little bit before. It's just a little bit less cluttered. And what you'll see here is we'll have a bunch of control plane pods, and Istio Citadel is the only really control plane element running on both the GKE and the on-prem side. Just one little note, some of the slides say GCP. I hope the Google guys don't get mad at me. This is all GKE based in our actual demo. So a little bit, a quick detail on what you'll see with respect to the application so you understand the flow of things. The application is based on what's known as the book info application that's commonly used in Istio for both testing and to display the power of Istio. So what happens is the user makes a request to the product page, but the actual service is decomposed into a couple microservices running different languages as shown here. And in the particular demo, we'll show you that the TAN, all the TAN pods are running on GKE, and we have a single microservice that's running on-prem to just be able to very easily see the routing between the two scenarios. And this, I have a little bit of an animation here showing you the actual flow of the client request. When the client makes when an external client makes a request to the product page, this is going to show you how the microservices work together to fulfill the final response back. So the end user will make a request. The product page itself will go to reviews to say, get me my reviews portion for that request. It'll also get the details portion from the details pod. Now the more interesting part, and what will be exhibited in the demo, is reviews itself needs to go to a rating service to get information on how many stars it should depict, and oops. And then finally, all this data from the different microservices is aggregated and sent back to the end user, the end receiver. So at this point, Robert will go into a little bit of details and show you some of the deployment.
Okay, so John just talked about the background and the architecture of Istio MultiCluster and also the booking for sample application deployment. So I'm going to go through the detailed deployment for Istio and the booking for application. There's not enough time to do a live demo here. So what we do is to pre-deploy, and we took some screenshots, and I'm going to go through that with you. So you can see on the screen we have two clusters. On the top is the GKE cluster we are going to use as the primary cluster, and on the bottom is the on-prem cluster. So the on-prem cluster is deployed in one of our DMZ sites, and between the clusters, the pod-to-pod networking is established by VPN. So now we are ready to deploy. There are many ways to deploy, and There is a documented procedure that you can find at istio.io site for multi-cluster deployment. In this demo, we choose to use this E2E booking for make target to deploy Istio and book info. So we execute this command in the primary GKE cluster, and as a result, the Istio control plane will be deployed over there. So the most significant flag is the cluster registry dir flag. So we store the kubeconfig of the remote cluster over there, and so the flag also signals the E2E test info. This is the multi-cluster deployment.
So just one, earlier I mentioned that we're using a preliminary version of the cluster registry. So it's a file-based, that's why you just see a file-based reference. Ultimately, that will probably migrate to like more of an API call. But at the time we did this, the cluster registry stuff was still quite a bit in flux, so we used the file-based approach.
So we also deploy the Istio and the book info in the Istio system namespace. So now we press the enter and the deployment started going. So basically, during this deployment, we generate the istio.yaml file for both the GKE cluster and the on-prem cluster, and we apply that YAML file in both clusters. So in the same time, we also generate the book info YAML file and apply it over in the GKE cluster. Now you can see the deployment is going on quite well. So now the deployment has been completed successfully. And in the GKE cluster, you can see the Istio control components have been started and running healthily. So these components will include like palette, citadel, mixer components, and the ingress and egress gateways. You can also find that the book info application is deployed over the GKE cluster, and we only have reviews version 1, version 2 are running there. So in earlier slides, you have seen that we have 3 versions of review microservices. So we only deploy the 2 versions of reviews over in the GKE cluster. On the bottom, you can see that the only Istio control component that we deployed is Citadel, and all the other components are not running over there. Here we show all the services that running in the clusters. So in the GKE cluster, you can see all the Istio services. They all have cluster IPs, and on the bottom, you can see the Istio services we have deployed over there, but all these services are headless and selectorless, except for Citadel. The reason we have them created over there is because the sidecars need to discover their IPs by means of DNS. Here we show all the endpoints that created in either of the clusters. For palette, it's only running in the primary cluster, and we create the endpoint in the on-prem cluster so that the IP can be discovered, and the sidecar running in the on-prem cluster can communicate with palette and discover the mesh configuration. Here we highlighted the external IPs for the Istio ingress. This IP is going to be used by browsers to access the bookinfo service. Now we are ready to deploy some of the bookinfo microservices in the on-prem cluster. So we only deploy the reviews version 3 in the on-prem cluster. In the same time, since the reviews service is going to call rating service, so we created a selectorless service ratings service in the on-prem cluster. This is for so that you can the review service can discover the rating service in the on-prem cluster. So after we have done the deployment of the review service, this is the result. This you can see on the on-prem cluster. So you can see the reviews version 3 is deployed and running, and the rating service is also deployed over there. So after deployment, so here we want to show you the Envoy configurations that Palette has generated. So basically, the sidecar will talk to Palette to find out all the XDS services configurations. So here we show the review service that has been configured to the sidecar, and for the review service, you can see the full DNS name, reviews.istio system.svc.cluster.local, and it also shows the sidecar should use SDS service to discover all the endpoints. Here we show that the sidecar is sending the SDS request to Pilot, and this is the return that Palette will respond. You can see that the IP address 192.170.228.84. That's the reviews version 3 endpoint that is running in the on-prem cluster.
It's a little difficult to see here, but the upper two stanzas are like reviews 1 and reviews 2, and the bottom stanza is the reviews 3. So the upper two are from GKE, the bottom one from on-prem.
Yeah, I think with that, I'm going to turn the podium to John. So he's going to show how to configure the route rules so that traffic can be steered between the clusters.
So I'm going to try to do this via live demo. Hopefully it all works. Let's see. Okay, so this is our cluster.
It's not showing on the screen. Do you have to share? I think you have to.
No, I don't have to share it.
You have to share it, or?
No, it's something on my screen.
No, it's not showing.
This might be a bit of a problem.
just show the video.
No, I can't show anything.
Maybe it's mine. Sorry about the technical difficulties. I think we want to display the screen rather than the PowerPoint. We want to show the screen on the. Oh, here you go. He's the expert.
Sorry about that. Where's my mouse?
Your mouse.
Oh, there we go.
I'll show you your VNC.
Okay.
Remember, you can do it this morning, right?
Yeah, I did it earlier.
So we want to have this screen.
Oh,
Here you go.
but I can't see my mouse.
You have to look at that.
I apologize a little bit for this, but these are the workloads, which were the same ones Robert was showing. Okay. Where's Okay. So this is the sample app, and right now we have, it's going to load balance a little bit between reviews 1 and reviews 2, which you can see by the stars, okay? And if we go up here, we look at the route rules. There's only a default rule. So now apply a different route rule. Not work. Oh, yeah. Okay, so now we have 2 route rules. And if I I go to here, now this particular route rule is only sends user JSON over to V3. So I haven't logged in as user of JSON right now, so I'll still get I should still get load balancing between V1 and V2. But if I sign in, I get V3. So the idea here is now that all this traffic, this could be like a canary, perhaps a canary install or something, but all the traffic for JSON, when JSON logs in, will be routed over to the pod on-prem. And we actually labeled the application slightly differently, so you can see that. Just so you can see that. I'll do it this way. Got it. Okay. So here's the actual YAML we use for that route rule. It's on JSON. I mean, pointing to only use JSON. So I had a few more examples, but considering the challenge of trying to type and hold my head sideways and everything, I think I'm going to skip those, and we can go to questions. Does anybody have any questions?
Yes, thanks. Great talk. Currently, the control plane for Istio, or most of it, that's in the primary cluster, so that makes that data center basically a single point of failure for me. Any plans on taking that forward to being able to make that geo-redundant as well?
Well, 2 points. The cluster itself is a single point of failure, but you can obviously do things like scale the pods and stuff like that to try to
Yeah, but it
help.
follows the whole data center, so.
Yeah, sure. In the Istio community has explored something that generally we've called this work multi-cluster, and generally we've called the other work multi-cloud, although we've sometimes been fuzzy on the naming. And the idea there would be you'd run pilot in multiple instances, and then you'd have the pilots talking to each other. So that would provide, more resiliency for that particular failure case.
All right, great, thanks.
In your example, you have two Kubernetes clusters, so you configure pilot via Kubernetes. Do you have an example of communication between a Kubernetes cluster and a non-Kubernetes cluster?
We haven't done that example in this demo. Actually, my peer here, Arvin, has done a lot of work with what's known as in Istio as mesh expansion.
And how do you tell the pilots how the cluster is then if you are not using the normal Kubernetes adapter? Did you write your own adapter?
So just so you all know, the question was, if you're not running a Kubernetes cluster on your other, where you want to run your other microservices, what do you do? Okay, and what we were just talking about, when everybody could hear, is that what you run is a little bit of pilot on the example scenario in Istio is what's known as mesh expansion, where it's a VM. So you run like a little bit of pilot over there on the VM. It's not a full control plane, but it allows the communication between pilot and the non-Kubernetes cluster. Any other questions? Yeah, so within the Istio community, we've talked a little bit about the service broker. Okay, the question was, have we thought about kind of combining this work with the service broker? I don't, my team, the team that's worked on this particular work, we haven't spent a lot of time looking at that. But within the Istio community, that's been a discussion point. So the only, besides the questions, I think the only, I had a reference slide that I'll try to pull up real quick, provide some pointers. How are we doing on time? Oh, we're right at time. So I'll just flash this real quick and then let you all go. So here's some references. It's in the slide deck that's posted if you want to get it. I think the only thing that I'd like to point out is we'd love to have anybody that wants to contribute to this work, extend it to other environments, extend it to non-Kubernetes environments. We've tested this work on on-prem. In an on-prem case, we've tested this with OpenStack-based VMs, with vSphere-based VMs. People are testing it with IBM Cloud, and we're going to try to plan to test this with 2 Kubernetes clusters. So there's definitely an opportunity for people to get involved here if they'd like. Thank you, everybody.